Hi guys, we're going to start with the chapter called mole concept. Very interesting, full of numericals and life. In this chapter, we're going to study about the 5 types of questions, right? The 5 types, the varieties, the 5 varieties of sums. We start with the first variety, the first type, which is called Gay-Lussac's law. Now, what exactly is Gay-Lussac's law? Simple language. When the gases, which are reactants, the gaseous reactants, they react, they combine together. When they combine together, they do it in volumes. We are going to speak in terms of volumes. For example, 3 volumes of hydrogen have combined with 3 volumes of oxygen to form some volumes of water. So we are going to talk in terms of volumes. Gay-Lussac's law is applicable only for gaseous substances, not any liquid substances. No aqueous nature. The reactants and the products both should be in gaseous form. So as I said, what exactly is Gay-Lussac's law? The gaseous reactants, when they combine in volumes, and it bears a simple whole number ratio to the volumes of the products form, provided the temperature and pressure of the reactants and the products remain the same. The last phrase was very simple. Temperature and pressure is constant. When the temperature and the pressure is kept a constant, right, no changes, okay, it is said to be, we had Boyle's law and Charles' law in 9th standard. Boyle's law, temperature constant. Charles' law, pressure constant. And we used to study about the volume, the behavior of volume. So always remember, we're going to talk about the change in volumes when the temperature and pressure remain the same. Alright, when we talk about the first question of my first type, so we have type 1. We have type 1. That's Gay-Lussac's. Gay-Lussac's law. Alright, talking about the numericals. In each type, we are going to take around 4 to 5 questions, right, in the crash course. Hoping that you will understand for the best, right. Let's start with the first question from my side. The question is, what volume of oxygen would be required to burn completely 400 ml of acetylene? And also calculate the volume of carbon dioxide formed. Alright, so we have oxygen and we have burning of acetylene. Acetylene, it is C2H2. Alright, this is a hydrocarbon. Acetylene reacts with oxygen. First step is always balanced chemical reaction. Whenever any hydrocarbon reacts with excess of oxygen, we get carbon dioxide and water. This is fixed. Let's balance it. Oxygen out here are 3, 2 plus 1. It's an odd number. I don't like odd numbers. Make a 2 out here. Now, 4 hydrogens. To make a 4, you can keep a 2 out here. Fine. Till now, hydrogen is balanced. 4 carbon, you can make a 4 carbon out here. Alright. And oxygen is 8 and 2, 10. To make a 10 out here, we can put a 5. So we have 2 C2H2 plus 5 O2 gives 4 CO2 plus 2 H2O. Now what we can do is, underneath the reactants, write down the volumes. What's that? Can I say 2 volumes of acetylene is used up in the reaction? So 2 vols. Underneath this 5 vols, 4 vols and 2 vols. Perfect. Alright. Now I have been told 400 ml of acetylene. So the total which we have in our experiment, in a laboratory, I am performing this experiment. How much acetylene do I have? I have 400 ml, which constitutes 2 volumes. So can I say, if 2 volume is equivalent to 400 ml, 2 volume gives me 400 ml, right? I can ask myself a simple question. It will be this. 2 into what is 400? Can I say 2 into 200 is 400? In simple language, 2 volumes occupy 400 ml. So one volume, will it occupy 200 ml? Yes. I call it as a multiplicative factor. I call that. It's my own. So this 200 is a multiplicative factor. Again, I'm reiterating. 2 into what is 400? 2 into 200 is 400. So the multiplicative factor is 200. So this is going to be multiplied with 200 throughout. So we have 400 ml of moisture produced, 800 ml of carbon dioxide produced, 1000 ml of oxygen used up, and 400 ml of acetylene used up, because the complete reactants were used up to give me products. So that's my answer. My answer is 800 and 1000 ml, right? Coming to the next question. So this was my first one for you all guys. Right, let's go with the second question. The second question is 3000 cc of oxygen was burnt with 600 cc of ethane. Calculate the volume of unused oxygen. So we have ethane, which is a hydrocarbon. Ethane formula C2H6. In organic chemistry, you have studied all these things. Plus oxygen. Now, obviously, a hydrocarbon plus oxygen gives carbon dioxide plus water. When you balance it, this is an odd number. Let's try with a 2. So, you have 4 hydrogen, problem. 4 hydrogen, you have 6 hydrogen out here. To make a 6, I can put a 3 out here. 3. But that 3 will make oxygen an odd number. Shit. So double it. Double the 3. Let's make it 4. Let's make it double, 6. 6 H2O. Why am I doing this? Look at the thought. Oxygen was an odd number out there. I tried to double it, but that was not fixing my balance with hydrogen. So I just made a double of it. So I made it 6. Hydrogen is 12. Hydrogen is 12. Carbon is 4. Carbon is 4. And oxygen is 8 and 6. 6 plus 8, that's going to be 14. 7 out here. This is the balanced chemical equation. Write down in terms of walls. I have 2 walls, 7 walls, 4 walls, 6 walls. And above that, I have been told oxygen is 3000 ml and ethane is 600 ml. Now, there are 2 competitive creatures out here. Here, I was only given this. So, it was easy. 2 into what is 400. So, I got 200 as the answer to my question. But out here, there are 2 people in the arena for competition. Let's start from here. 2 into what is 600? Can I say 2 into 300? 2 into 300 makes it 600. So the multiplicative factor is going to be 300 as of now. So everything 7 into 300, 4 into 300 and 6 into 300. So this makes it 600 ml. This makes it 2100, 1200, 1800. Now please tell me one thing. How much oxygen did I have? I had with me 3000 ml, out of which 2100 is used up, because these are reactants. They are used up to give me products. So tell me one thing, all of y'all, that out of 3000 which I had, 2100 is gone out, used up. How much is left? Subtract. 900 ml of oxygen is unused. So this multiplicative factor was perfect. If I take this as the multiplicative factor, 7 into what is 3000, approximately you will get an answer which is going to be in decimals. So 7 into what is 3000? Let's calculate now. 4s are 28, 2s are, it will be 400 and something. 400 and something, right? So if I say 400 will be the multiplicative factor, this answer also would have been an absurd answer, because 2 into 400, 2 into that multiplicative factor, that decimal thing, would have given me something more than 800. How much do I have with me? I have only 600. How can I use 800? Are you understanding? It's very difficult to explain on the camera, yaar. If we are face to face, I can take you on a roll. Out here, listen. If this would have, I would have started with this as my multiplicative factor. It would have been 7 into approx 400. Let's take now. It's 3000. So the multiplicative factor would have been 400. So everything would have been multiplied with 400. Ah, there you go, man. This also would have been 400. 2 into 400 is 800. I have 600 only. How can I use 800? I don't have. Where will I get it from? Hence, this is a proper multiplicative factor. So now I can say that the unused oxygen is 3000 minus 2100, which is 900 ml. Perfect. Right. Let's go with my third numerical. Oh, the nice one this is. The mixture of 10 centimeter cube of carbon monoxide, 60 centimeter cube of hydrogen and 25 centimeter cube of methane are mixed with 750 centimeter cube of air containing 20% of oxygen, and it is ignited. Calculate the composition of the resulting mixture on cooling. Underline the word on cooling, at room temperature. So we have three reactions involving oxygen with us. The first one is carbon monoxide. The second reaction with us is hydrogen. And the third reaction which I have with me out here is CH4, that is methane. They are all ignited with oxygen, that is O2, O2 and O2. Alright. Can I say carbon monoxide plus O2 will give me carbon dioxide? If you balance it, this is going to be 2 and a 2. H2 plus O2 gives me moisture, H2O. Balance it, 2 and 2. Any hydrocarbon plus oxygen gives carbon dioxide plus water. Right. If you balance it, oxygen is odd out here. You make it 2 to start with. 4 hydrogen, 4 hydrogen. Alright. 1 carbon, okay. 2 and 2. That's it. That's balanced for y'all. So all the three equations are balanced. Just underneath them, you can write down the walls. 2 wall, 1 wall, 2 walls. 2 wall, 1 wall, 2 wall. 1 volume, 2 volumes. That's what I said. Gay-Lussac is about the volumes. 2 walls. Now what is given is, I have been told 10 centimeter cube of carbon monoxide. Alright. So 2 into what? What is 10? Can I say 2 into 5? So the multiplicative factor is 5. Right. Hydrogen given to me is 60 centimeter cube. cc, cubic centimeter. 2 into what is going to be 60? Can I say 2 into 30 is going to be 60? So the multiplicative factor is 30. Methane given to me is 25 centimeter cube. 1 into what is 25? 1 into 25 is 25. So this will be 2 into 25, 1 into 25, 2 into 25. Perfect. Now after this, let's see how much we get in the first reaction. We have 10 cc of carbon monoxide, 5 cc of oxygen used up, and 10 cc of carbon dioxide formed. That's till now. In the second one, we have 60 cc of hydrogen used up, 30 cc of oxygen used up, and 60 cc of moisture obtained, formed. Alright, next one. 25 cc, right? 25 cc of what? Of methane used up. Then we have 50 out here. cc of oxygen used, 25 cc of carbon dioxide, and 50 cc of moisture. Alright, now I have been told, guys, that we have 750 cc of air. Now always remember, out of 750, 20% is oxygen and the remaining 80% is nitrogen. All the other gaseous products can be neglected, like dust particles, carbon monoxide, carbon dioxide, H2S, anything. You can neglect them. These are major components. Right. So can I say 20% of air is oxygen? So I can say 20% of the air, total air, isn't that oxygen? That's how much I have with me, guys. So oxygen with me in my hand is 150 centimeter cube. So nitrogen will obviously be 600 cc. Come on, 20% of this is air, which is 150. Out of 750, if 150 is gone, oxygen, what is left out? Nitrogen, that's 600 cc. Now tell me one thing. Out here, oxygen used in this reaction is 5. This reaction, oxygen used is 30. And this reaction, oxygen used is 50. So, all of y'all, oxygen used up is 5 plus 30 plus 50. That's going to be 85 cc of oxygen is used up. So how much oxygen is left unused, remaining after the reaction? 150 I used up 85. Damn, I have how much oxygen left with me? Isn't it 150 minus 85, which is going to be 65 centimeter cube of oxygen is unused. In my reactants, everything is used up except for oxygen. So I can say the unused oxygen is gonna be 65 cc. That's one of my answers. In the products, carbon dioxide is 10 and 25. So the total carbon dioxide formed is 35 cc. Moisture is 60 and 50. I won't speak about it. Sorry. That's the catch. Haven't I told you all that whenever the word cooling comes, this moisture turns into water, condensation. And Gay-Lussac's law, guys, is applicable only for gaseous products and reactants. Hence, I will not consider water as my product as a gaseous reactant. So, if someone asks you what is the resulting mixture, the final mixture is 65 unused oxygen, 35 carbon dioxide, and nitrogen 600. But moisture should not be written, right? So these are 3 sums which I have taken from Gay-Lussac's point of view. All right, just go through them and we shall now go with the next part, the next concept, yeah, and that is percentage composition. Starting with the next type 2, percentage composition. All right, so we have percentage composition. Right, very simple type once again. What is percentage composition? It is the percentage by weight, mass of an element which contributes its weight in the entire compound. For example, there is a compound consisting of carbon, hydrogen and oxygen, right? So there will be some contribution of carbon by weight in that entire compound. There has to be some contribution by hydrogen and oxygen respectively. Yes, so that is called percentage composition. It is the answer in terms of a percent by weight of an element in a given compound. So let's take 3 sums out here, around 3 to 4 questions, which will make me thorough. Calculate the percentage of potassium in potassium bicarbonate, right? Potassium in potassium bicarbonate. So first thing, step 1, you write down the compound potassium bicarbonate, KHCO3. That's the formula. We have 1 atom of K, potassium, plus 1 atom of hydrogen, plus 1 atom of carbon and 3 atoms of oxygen. So 1 K, 1 hydrogen, 1 carbon, 3 oxygen. Lovely. The molecular weight, this is what I'm finding out. When I get an answer, that will be the total weight, the molecular weight of this compound. The individual weights will be given in the exam. For example, potassium is 39 grams, hydrogen is 1 gram, carbon is 12 grams, and that's 1 into 12, come on, and oxygen is 16 grams. Add it, 39 plus 1, 40, 40 plus 12, 52, plus 48, that's 100 grams. So the molecular weight of this compound is 100 grams. I am asking you, what is the percentage by weight of potassium? Tell me one thing, how much is the contribution of potassium in this entire 39 grams? So can I say percentage of potassium is 39 upon the total molecular weight, and it's a percent means into 100. So isn't my answer 39%? That's it. If I ask you percentage of oxygen, it will be 48 upon the total into 100. Oxygen contributes 48% of the weight in this entire compound. Alright. So this was one type of question which we encounter in the board exam. The second type of question, good one. It's a nice question. Let's read it out. Alright. The question is, calculate the percentage of carbon, percentage of carbon in a 55% of pure sample of calcium carbonate. We have calcium carbonate. I want percentage of pure carbon. Alright. Calcium carbonate, I think that's CaCO3. I want percentage of pure carbon in a 55%, pure sample, in 55% purity, pure sample. Let's understand the question. First, let's do one thing. Let's find the entire weight, the molecular weight of this compound. So we have 1 calcium plus 1 carbon plus 3 oxygen. Now, this is the molecular weight. Calcium is 40 grams, it's given. Carbon is 12 grams. Oxygen is 16 grams. That's going to be 52 plus 48. Luckily, 100 again. So can I say we have 100 grams of molecular weight of this entire compound? Out of which, tell me how much is the contribution of carbon? Carbon is only 12 grams. So guys, what I can say is, carbon weighs 12 grams of 100 grams. That means out of 100 grams, the weight contribution of carbon is only 12 grams. Fine. Now, I know that it is only 55% pure sample. Now listen. This 12 grams of carbon which I got 12 grams of carbon. See, it's in my hand. This carbon, 12 grams, is pure plus impure. It's a mixed carbon, out of which only 55% is pure. So I can say percentage of pure carbon, isn't it going to be 55% of 12? Yes. So 55% of 12. You multiply 55 12s are. That's 550 plus 110, 660 I guess. 660 upon 100, right? And that makes it 6.6 gram. So I can say what is asked in the question. In the question it is asked how much percentage of pure carbon do you obtain? Alright, it is the same answer. Percentage of pure carbon in this entire sample is only 6.6%. That is 6.6 grams, which also is a percentage because it is upon 100. Right? A nice question. I did simple thing. Out of the total weight, I first pulled out the total carbon. From that total carbon, which is pure plus impure, I know only 55% is pure. So 55% of that carbon, which contributes to the total weight, is pure. Right. My next question is, hydrated calcium sulfate, that is CaSO4 dot some molecules of water. That's what I have to find. Hydrated calcium sulfate contains 21% of water of crystallization. Calculate the number of molecules of water of crystallization in this compound. Nice question, guys. So this was the second one for your first one. The third one. Look, we have calcium sulfate hydrous. That is going to be CaSO4. I know the answer is 2H2O. Hey, come on, I know that. I'm better than you all. It's not about me knowing it. This is what I have to prove. They are asking me, how many water molecules does this compound have? Can I say, come on, yeah, let it have X water molecules. I need to find this. I know the answer is going to be 2. We will prove it, na? Okay. When I'm heating this, heat, this breaks up. Calcium sulfate becomes anhydrous without water. The water is lost. So you get anhydrous calcium sulfate and you get X number of water molecules are vaporized because of heating. Fine. So it's separate. Let's find the molecular weight of this and this. Come on. Molecular weight. Calcium is 40 grams. Sulfur is 32 grams. Water is 16. So 4 into 16. Sure. 40 plus 32 gives me 72 plus 64. That makes it, hey, come on, it's the 64. Yeah, 40 and 24. Perfect. That makes it 136 grams. So the weight of calcium sulfate anhydrous is 136 grams. Hydrogen is 1 plus 1, 2 grams and oxygen is 16. Multiplied with X. It's not one water molecule, yeah. There are X water molecules. So the answer is 18X. 18 into X. That is the weight, the mass of X total water molecules in this compound. Right. Can I say, when you heat this up, it gives me 136 grams of CaSO4 along with 18X grams of water. That is how the split up is. I have been told in the question, water which is formed, yeah, this one, this. Water which is formed is only 21% of the total. Only 21%. So now we have 21% of water of crystallization. So out of 100%, if 21% is water, can I say 79% is going to be anhydrous calcium sulfate? Cross multiply. 136 grams, okay, fetches me 18X molecules of water. And if this is 79%, the equivalent percentage of water formed is 21%. Unitary method, cross multiply. I'll just solve it up. 136 into 21, that's 21%. 21 upon 100 is equal to 18X into 79%. That's 79 upon 100. Cancel this. Alright, you want X. So you have 136 into 21 upon 18 into 79. This is equals to X. When you solve this, you will get an answer as 2.008 approx. And can I say that is as good as 2? That means there are 2 molecules of water present as water of crystallization in hydrous calcium sulfate solution, right? So that was my type 2 percentage composition. Go through this, and my next one for y'all is empirical formula. Alright guys, let's proceed with the next type, the third type, empirical formula. Very important. Usually a 5 to a 6 mark question comes from this. So type number 3, empirical formula. What exactly do you mean by empirical formula? Empirical formula is actually the formula of a compound, right, which gives a simple whole number ratio. A simple whole number ratio between the atoms of the elements in a compound. You don't understand much by this definition. I keep it very simple. It's a formula which tells me that in a compound, how many carbon atoms are there, or hydrogen atoms are there, or in that case sulfur or oxygen atoms are there. So it's a simple formula which gives me the number of atoms of that element in the compound, and it's a whole number. You can't have half atom of carbon, 1/4 atom of oxygen. No, you have complete atoms here. 6 atoms of carbon, 14 atoms of oxygen. You have a whole number ratio. That's empirical formula. In order to solve sums on empirical formula, I by heart a table, a format, and the 5 steppers. I have made this. The format, the tabular format is, in the first column, we will have 5 columns. The first column will have element. Which element is present here? That. Second will have the percentage composition which will be given of that element. The third column will be the atomic mass, atomic weight of that element. The fourth will be relative number of atoms. RNA, don't use that in the board exam. It is relative number of atoms. And the last one is Swener. That's simplest whole number ratio. Simplest whole number ratio. So I've just given you a shortcut to remember these 5 columns. After you fill in this, we have a 5-stepper. Step number 1. It is going to be empirical formula. We'll see here what it is. Wait now. Then we will see empirical weight. The third step is going to be finding out the vapor density, that's molecular weight. Molecular weight, we have a formula, it is 2 times the vapor density. Step 4 is about finding the number of atoms, which is, the formula is molecular weight upon empirical weight. And finally, step 5, we are going to find out the molecular formula, which is going to be the empirical formula to the base n. So this is going to remain fixed for almost any sum of empirical formula. The tabulated sums, obviously. Let's start. We're going to take 3 sums of empirical. Let's start with the first question. Alright. All of you all pay attention. The first question is, a compound of CHO, carbon, hydrogen and oxygen, they are found in the proportion, in the percentage as 40% of carbon, 6.7% of hydrogen, and the remaining percent is oxygen. If the vapor density is 30, calculate the molecular formula of such a compound. Let's start. We start with the same tabulated method. Element, percentage composition, atomic number, relative number of atoms, and simplest whole number ratio. Let's begin. Okay, the element is carbon, hydrogen and oxygen. So we have 3 elements. Perfect. The percentage of carbon, 40%, it's given to me. Hydrogen is 6.7% and oxygen is going to be 43.3%. The weight, atomic number, it's not atomic number, it's the atomic weight. Come on, atomic weight. Atomic weight of oxygen is 16, hydrogen is 1 and carbon is 12. To find the relative number of atoms, we are going to do the second column. This is the second column. This is the third column. We're going to divide both of them. Second column divided by the third column. So it is going to be 40 upon 12. This is going to be 6.7 upon 1. And this will be 43.3 over 16. So I have done divisions. My answers will be approx. This is 3.33. This is 6.666666. That's 6.7. And this is also 3.33. When you perform the actual division, yes, we'll get some answers like this. Perfect? Right. Okay. This, I've just made one minor error. This has to be 53, right? This should be 53. Yeah, of course, man, like 46 and that's 53 to make it 3.33. All right, so I have done with this till now. Now tell me one thing. I'm talking about simplest whole number ratio. How will you find this out? Out of all 3 of them, which is the smallest? I guess out of all 3 of them, the smallest is 3.33. Divide each of them with the smallest. So I can say 3.33 divided by 3.33, that's going to be 1. 6.7 upon 3.33, approximately 2, very close to 2. And 3.33 upon 3.33, 1. So we have 1, 2 and 1. That means 1 atom of carbon, 2 atoms of hydrogen, 1 atom of oxygen. So we start with step number 1. First stepper. The empirical formula is going to be C1H2O1. Let's talk about the empirical weight. 1 carbon 12 grams, 2 hydrogen 2 grams and 1 oxygen 16 grams. That makes it 30 grams. Alright, third step. The molecular weight, isn't it 2 into the vapor density? That's 2 into 30 and I guess that's going to be 60 because vapor density is given in the question. Perfect. And next, N is going to be molecular weight upon the empirical weight. I think that's going to be 2. And finally, we have the molecular formula. It is going to be the empirical formula, that's C1H2O1 to the base 2. That's going to be C2H4O2. And that's how I get my molecular formula for the given compound. It was very monotonous. It was very simple. You just have to blindly follow these steps and arrange the data. Where students go wrong is the calculation part, the division part. Even if you can't do division, then you are hopeless. At least you should do this division properly. Can't you divide division method? Yeah, 6 standard. Yeah. 40 inside and 12 outside. In a rough column, obviously you can do, right? Go through the sum. 2 more to go for such a type from my end. The second sum on the empirical formula. A compound has the following percentages composition. Sodium 18.60%, sulfur 25.80%, hydrogen 4.03% and oxygen 51.58%. Alright. Assuming that in the compound, at the end, you need to remove the water of crystallization or you have to calculate the number of water molecules of water of crystallization. Okay. Molecular weight of this compound is given to me as 248. Find the molecular formula of the compound. Simple. Let's begin with that table. Table, the first one, second sum of type 3. We have element, we have percentage composition, then we have atomic weight, mass, we have relative number of atoms, and we have simplest whole number ratio. Board exam, you have to write full form. Shortcut not allowed. So the elements are sodium, sulfur, hydrogen and oxygen. Perfect. Percentage. Sodium is 18.60%. Oxygen is 20, sulfur is 25.80. Hydrogen 4.03, oxygen 51.58. Percentages given in the question. Atomic weight. Sodium. I guess sodium is how much? Come on. 23 grams. Sulfur 32 grams. Hydrogen 1 gram. Oxygen 16 grams. Relative number of atoms, divide them. It's always the second column upon the third. Second upon the third. So you have 18.60 upon 23, 25.80 upon 32, 4.03 upon 1 and 51.58 over 16. You get this answer when you calculate the actual division method, you get 0.80. This you will get it as same 0.80. This is going to be 4.03. This is going to be 3.2 something. 3.2 something. Now out of all of them, which is the smallest? Come on, the smallest, the baby is 0.80. Out of all four, this is the smallest. So what you do is, you divide by the smallest term. If you divide this by itself, it's going to be 1, 1. 40 upon 8, 5. 32 upon 8, 4. Talking about the first stepper. Step 1. It was the empirical formula. Right? It is 1 sodium, 1 sulfur, 5 hydrogen, 4 oxygen. So any one, I don't write 1. Let's write 1 for you all, yeah. Sulfur 1, oxygen 5 and oxygen 4 I guess, and hydrogen 5. It's okay, no, any order you can write it down. What difference does it make? Right. Talking about the weight, stepper number 2. That's empirical weight for y'all. Sodium 23 grams, sulfur 32 grams, oxygen 16 into 4 atoms. 16 fours are 64 grams. And hydrogen is 1 into 5, that's 5 grams. Calculate it, man. 23 plus 32, 55 plus 5, 60 plus, yeah, that's going to be 124 grams. That's the empirical weight. I have been given directly the molecular weight. It's given. It's given to me as 248 grams. It's given in the question. Step 4. Number of molecules is 248 divided by 124, which is going to be 2. So I get N as well. And the last stepper, step number 5, the molecular formula. It is going to be the empirical formula, that is Na1S1H5O4 to the base 2. So that should be Na2S2H10. 8 oxygen. Now, it's not over. Sorry, it's not over. Out of this, I need to separate the water of crystallization. Water is H2O. Tell me one thing. We have 10 hydrogen. In 1 molecule of water, I need 2 hydrogen. I have 10. So obviously, I can prepare 5 water molecules. Because 5 2s are 10 hydrogen and 5 1s are 5 oxygen can be used up in making it the water molecules. So the remnants are Na2, H2, O3. Oh my God. Why O3? Because out of 8, 5 are used up in water. So can I say 5 plus 3? Damn, yaar, it's 8, no. So Na2H2O3 with 5 water molecules, we call such a compound, just for your knowledge, as sodium thiosulfate. It is there in HCl chapter. It is one of the most important reactions in the textbook. It will come ahead when you do the crash course of HCl. So it is sodium thiosulfate. To be more precise, it is hydrated sodium thiosulfate. Right. So these are my two questions of empirical which I have selected for you all. Let's go on with one more. The next one, slightly different. The question is, to determine the empirical formula of sodium, sulfur and oxygen, whose percentage composition of sodium is 29.11%, sulfur 40.51% and oxygen 30.38%. Right. What you have to do is, you have to just determine the empirical formula, not the molecular formula. So it's a smaller question. But why did I select this as one of my questions? Slight variety, a new concept to be introduced in this sum. Right. Starting with the same monotony. Element, percentage composition, it's all in the blood now. Atomic weight, RNA, not ribonucleic acid, that's not a component of, something like DNA. And Swener. Stupid, now it sounds, but come on, it is. Simplest whole number ratio. Element is, I guess I just forgot. Sodium, sulfur. Sodium, Na, sulfur, S and oxygen. The percentage given to me in the question, 29.11. Oxygen, sulfur is 40.51. And oxygen is 30.38. Atomic number of sodium is 23, sulfur 32, oxygen 16. Relative number of atoms, you divide both of them. 29.11 divided by 23. Then you divide these two and you divide these two. On division, you get answer as approx 1.2. This answer, 40.51 divided by 32, is approx, I guess, I've just calculated it out here. It's 1.2 again. If you put it further, 1.266. And the last one I have calculated as 1.89 approximately. Come on, I've just divided here. Yeah. Which is the smallest of all three of them? I guess it's 1.2. So if you divide each of them by the smallest of them, divide each of them by the smallest of them, this will be 1, this will be 1, this, the last one, 1.89 upon approx 1.2. Come on, 1.8 divided by 1.2 approximately. That's shift the decimal. 3 by 2, that's 1.5. You can't round it off to 2. Rounding off concept is never allowed. It's a huge round off. If the rounding off would be something like 1.99, I could have rounded off to 2. Yeah, but 1.5 and 2, damn, it's a huge difference. What to do in such a predicament? If it is 1.5, start multiplying it with the whole number which starts from 2. Whole number starting from 2, start multiplying. 1.5 into 2, does it give you a whole number? Yeah, of course, man. It gives me 3. So you multiply each by 2. I am repeating. Whenever you have a decimal which is very prominent, you can't round it off. You start multiplying slowly with the whole number which is the least whole number as 2. If it would have been 1.4, just a thought, if it would have been 1.4, into 2 would have fetched me 2.8. Into 3, into 4, nope. Into 5, yes. 5 into 1.4 would be 7. Yes, so I want a whole number as my answer. So that's how we do it. So I have the empirical formula as sodium 2 atoms, S2O3. Isn't that again sodium thiosulfate without water of crystallization? Alright, so these were my 3 examples from empirical formula. We jump to the 4th concept, which is the Avogadro's number and vapor density. Okay guys, we're going to start with the mole concept, the Avogadro's number and the vapor density. What exactly is a mole? Now we are going to use a story concept. I call it as a story. Okay, I'm going to teach you in terms of a simple fictional story. What exactly is a mole? Mole is the amount of substance. Let's say there is some substance in my hand. I call it as 1 mole. Mole is the amount of substance present with me which has the same number of units, which has the same number of particles as in 12 grams of carbon atom, right? So if I have 1 mole of nitrogen, right? That mole of nitrogen will have the same number of units. It will have same number of particles as that of 12 grams of carbon atom. Remember, then there is something called as Avogadro's number. Avogadro's number is a value. Okay, Avogadro's number, we say there are 6.023 into 10 raised to 23 particles or molecules or ions present in 1 mole of a substance. So if I have 1 mole and if I count in that 1 mole, there will be so many 6.023 into 10 raised to 23 particles of any atom whichever you take. That number is Avogadro's number, right? And there is something called as vapor density. Vapor density, vapor, pressure, air, density, the weight, the mass upon volume. I can say vapor density, there is a formula. It is a ratio. It's a ratio of mass of a substance having a particular volume to the mass of hydrogen gas of the same volume. The volume of that substance and the volume of hydrogen should be the same. Then only I can say it is a ratio, something upon something. Whose ratio? Mass of a substance to mass of hydrogen, both should have the same volumes. Right. With this, I'm going to take certain sums which are based on mole concept and Avogadro's number. First thing, remember this as a story. The first liner, 1 mole of any substance, any damn substance on this earth, right? 1 mole occupies the molecular weight. So if there is 1 mole in my hand of, let's say, carbon dioxide, then the weight will be 44 grams. Carbon is 12, oxygen is 16 into 2 because it's O2. 32 and 12, 44 grams. So it will occupy, when we weigh it, it's going to be 44 grams. So always remember, 1 mole of any damn substance on this earth weighs its molecular weight. It is measured in gram. It occupies the volume of 22.4 liters or 22.4 decimeter cube, or you can say 22400 centimeter cube or 22400 milliliters. These are different conversions. This is the volume at STP of any gas of 1 mole. Having the molecular weight occupies this much volume, and that gas will have 6.023 into 10 raised to 23 either particles or ions or molecules. In the textbook, they have also given atoms. I wouldn't say that it's always true. I come to that atom concept after a while. So I should remember this as a flow chart. It goes in a smooth, random manner, no changes at all. This value is fixed. This value is fixed. It's never going to change. What keeps on changing? It is only the molecular weight. of substance keeps on changing. So let's use this tabular format to start with the first sum. Let's begin. The first question, calculate the number of moles of nitrogen in 7 grams of nitrogen, wherein the atomic weight of nitrogen given to me is 14. So listen, can I start with the trend? 1 mole of nitrogen, the first question. 1 mole of nitrogen, can I say nitrogen is N2? It's a diatomic molecule. Occupies the molecular weight, that is 28 grams. Because nitrogen is 14 into 2, 28 grams. That is the molecular weight. They are asking me that how many moles, so can I say X moles, under the mole I am writing, will occupy 7 grams. There is no need of Avogadro's number or volume in this sum. There is only a connection between the moles and the molecular weight. Nothing about the liters, the volume and the particles. Cross multiply. 1 into 7 is equal to 28 into X. Get the 28 down. 7 upon 28 is equals to X. So can I say X is 1 by 4? That's going to be 0.25 moles. So in my first sum, we have a relation between the mole and the molecular weight. Let's proceed with the second question. So this was my first for you. Alright, the second question. Question is, calculate the mass of 50 cc. Cc is cubic centimeter, centimeter cube. Calculate the mass of 50 cc of carbon monoxide at STP. Now, mass means I'm talking about the molecular weight, and they have mentioned about the volume. So in my second sum, we have a relation between the weight and the volume. We have nothing to do with the number and the mole. So let's go with the flow. We are talking about the substance called carbon monoxide. Can I say the molecular weight of carbon monoxide is 12 and oxygen is 16. So the molecular weight is 12 plus 16. That's going to be 28 grams. 28 grams of carbon monoxide occupies 22400 cubic centimeter. They are asking me how many grams, what should be the molecular weight, what should be the weight, so that this gas will occupy only 50 cubic centimeter. Cross multiply. X into 22400 is equals to 50 into 28. So X is going to be 50 into 28 upon 22400. You cancel this. Alright, 5 ones are 5, 4s are 20, 5 4s are 20, 448. 7, shall it go? Yes. 7 4s are 764s are, and 4 ones are 4 ones are 16s are. So answer is 1 by 16. That's the answer. 1 by 16 grams. You can put it in decimals. I think 0.0125, whatever the answer is. 0.0625 when you cut it. Right. So my second sum was the relation between weight and the volume. First was a relation between mole and the weight. Next question. Calculate the number of molecules. Number of molecules means the last column. This one. Calculate the number of molecules in 1 kg of sodium chloride. Right. So the substance, the compound is NaCl. It is sodium chloride. They're talking about the number of molecules, this one, in 1 kg. 1 kg is the weight, the molecular weight, the weight I can say. I'm talking about this column and I'm talking about this column. So the connection is between this and this. We don't want this in the sum, we don't want this. So can I start? NaCl. Yeah, NaCl, the molecular weight. Sodium is 23, chlorine is 35.5. So I get 58.5 as the molecular weight. Goes with the flow. 1 mole of NaCl occupies the molecular weight, which is 58.5 grams. It occupies 22.4 liters and it occupies 6.023 into 10 raised to 23 molecules. Then in 1 kg, 1 kilogram is 1000 grams. What should be the number of molecules? Cross multiply. You get X as 6.023 into 10 raised to 23 into 1000 upon 58.5. Alright, that should be the answer. This cutting and all, you can do it by yourself. It's very simple. So till now we have seen a relation. It's a very simple sum, these mole concept and Avogadro's sum. It's just based on this simple flow chart. Go through these 3 sums. I have a couple of sums more for you. Alright, the next question. 1 mole of SO2 occupies 24 dm cube of volume. Find the mass of 6 liters of SO2. Now wait, before me going further, let me write the story. Let me write that link, that flow chart, right? I can start this way. Yep. 1 mole of SO2 in this sum, or 1 mole of anything, occupies the molecular weight. Occupies 22.4 liters, of course. But in this question, they are demanding, they are ordering me that listen, it should not be 22.4, it should be 24 dm cube. So I have to listen to them. Alright, this is what is given till now. I have been asked, okay, I have been asked first, find the mass in 6 liters. Mass means I'm going to talk about the weight. Liters, I'm going to talk about this. Remember, I just wrote few minutes back. Decimeter cube is as good as liters. It's the same thing, no conversion. Right, let's start. 1 mole of SO2 occupies the molecular weight. Molecular weight of sulfur. Sulfur is given to me as 32. Plus oxygen is 16. 16 twos are 32. So can I say it is 64 grams? So 1 mole occupies 64 grams. And it occupies 24 liters. Fine. I have been asked what is the mass. Can I say under the mass I'm going to put X in 6 liters. Cross multiply. So you will have 24 into X is equal to 64 into 6. X is equals to 64 into 6 over 24. 6 ones are 6 fours are 4 ones are 4 16s are. So can I say 16 grams is the first answer. Second, they're asking me volume occupied by 80 grams. Same thing. Mass is given, volume is to be obtained. We know the basics, the molecular weight, and this remains fixed. Now I have been told out here we have 80 grams of the sulfur dioxide. What is the volume? Volume I have to find out. Cross multiply. 64 into Y is equals to 80 into 24. So Y is equals to 80 into 24 upon 64. 8 tens are, 8 eights are, 8 threes are. So can I say it occupies 30 liters or 30 decimeter cube. The next part, third, the number of molecules in 0.64 grams of sulfur dioxide if 1 mole contains n number of molecules. For the first time, they have told me not to use the value of Avogadro's number. They have told me instead of writing the Avogadro's number, select n molecules. So obviously, can I say that 1 mole occupies molecular weight occupies 22.4, but for this sum, they have ordered me to use 24. Also, they have told me get the answer in terms of n. Basically, n is that number of Avogadro, right? 6.023 type wala number. So out here I have to use n only. Okay, the theme remains the same. They are asking me in 64 grams, which is the molecular weight, occupies n molecules. If, I'll do it out here, if 64 grams, so if 64 grams occupies n molecules, then 0.64 grams will occupy how many molecules? Cross multiply. Get it down. So Z is equals to n into 0.64 upon 64. Now when you shift the decimals, or you can directly cut it out and say n into 0.01. So the Z is going to be 0.01 n. So these many number of molecules will be occupied. Perfect. And the last part, the weight of 0.5 gram molecules of SO2. Now we have a simple formula, the gram molecules, right? Gram molecules, it is weight in grams upon the molecular weight. I have been given in 0.5 gram molecules. The weight in gram is to be obtained. And the molecular weight, come on, we know the molecular weight. Isn't the molecular weight 64? 0.5, you cross multiply. 64 into half. 0.5 is 1 upon 2, half. Come on. So when you get the answer, you get 32 grams as the weight in grams of SO2. Right? So this was my very beautiful question. Very nice question. Okay. Talking about the last one from my side in mole concept in the crash course. Calculate the number of moles, the number of molecules, the number of hydrogen atoms, and the total number of atoms in 294 grams of sulfuric acid. Now sulfuric acid is going to be H2SO4. Perfect. Let's start with the flow, right? That flow. I can start this way. 1 mole of H2SO4, that's sulfuric acid, occupies the molecular weight. 2 hydrogen, 32 sulfur, and 16 fours are 64 for oxygen. That makes it 98 grams, which is the molecular weight. It occupies 22.4 liters and it occupies 6.023 into 10 raised to 23 molecules. I wouldn't say atoms, sorry. We are going to talk about H2SO4. Let's begin. Can I say they are asking me that in 294 grams, first, what are the number of moles present? If 1 mole occupies 98 grams of weight, then how many moles will constitute 294 grams? Cross multiply, you get answer as 3 moles. That means I am working with 3 moles in my experiment right now. In the test tube, I have how much? 3 moles. Okay, with what I'm working with now. Fine, that's the first part of the question. Second, they're asking me the number of molecules. All right, 1 mole occupies these many molecules. Then I am working with 3 moles, damn. If 1 mole occupies these many molecules, 3 moles will occupy how many molecules? Cross multiply. So the answer to the second one is going to be 3 into 6.023 into 10 raised to 23 molecules. Third, find the number of atoms. Now that's beautiful. In 1 mole, I have 2 hydrogen, 1 sulfur, 4 oxygen. can I say I have 7 atoms in 1 mole, 1 mole of H2SO4. So I am working with 3 moles. So if 1 mole has 7 atoms, 3 moles will have 21 atoms, right? So I have to find out the total number of atoms. In 1 mole, okay, 1 mole has so many molecules. 1 mole has so many molecules. So 3 moles will have these many molecules. 1 molecule has 7 atoms. 1 molecule has 7 atoms. So total number of atoms, will be 7. Yeah, 7 into 3 moles, because 1 mole or 1 molecule has 7 atoms. So 3 of them will have 7 into 3 into these many. Atoms. And if I ask about the number of hydrogen atoms, yes, the number of hydrogen atoms. In 1 molecule, there are how many hydrogen atoms? Please tell me. There are 2 hydrogen atoms. We have 3 such moles. So it's going to be 2, because in 1 of the mole we have 2 hydrogens. So 2, we have 3 such moles and we have so many molecules. Hydrogen atoms. If I ask about sulfur atoms, it is going to be 1 into 3 into this. If I ask about oxygen atoms, it's going to be 4 into 3 into this. If I ask about hydrogen atom, it's going to be 2 into 3 into 6.023 into 10 raised to 23 atoms, right? So this was about my selection of few sums from mole concept. We're going to talk about few sums of vapor density, and then we shall finally jump with the chemical equations. Hey guys, moving on with the next concept, and that is going to be the vapor density concept. Yeah, this is your type number 5. I call it as VD, vapor density. Okay, now what is vapor density ideally? We'll see a formula and we'll see what exactly do you mean by that. It is nothing but the density of a gas with reference to hydrogen gas. Density means you can say sort of vajan. Mass upon volume is density. So density is nothing but the weight of the gas, something like that. Yeah, we'll see what exactly is vapor density. Hold on. First, we have studied a formula in empirical formula that molecular weight is 2 into vapor density. Another formula. Vapor density is weight of a certain volume of gas, upon weight of same volume of hydrogen gas. That means you take any gas जिसका density ढूंढना है, जिसका vapor density ढूंढना है, so weight of हमारा gas, the one which I want, upon weight of same volume. Now this word is very important, same. Now the formula can be used if and only if the volume of both of them are equal. Formula is of weight. I know formula relates the weight of the two gases, लेकिन you can correlate them only if their volumes are the same. Another way I can write the formula, you can say weight of 1 liter of a gas, make it fixed. 1 liter 1000 milliliter upon weight of 1 liter of hydrogen gas. Yeah, that gives me a clearer picture that दोनों का volume is 1 liter. So it is basically weight of gas, the one whose vapor density is to be obtained upon weight of hydrogen. So this is the formula for vapor density, my friends, right? Let's go on with the first question straight away. The question from my side is 500 ml of a gas X at STP, standard temperature and pressure, weighs 0.5 grams. Calculate the vapor density and molecular weight of a gas if 1 liter of hydrogen at STP weighs 0.09 grams. Listen, it's a simple question. So the first question, we have a gas X. The gas name is X. 500 milliliter. 500 milliliter का वजन is 0.5 grams for X. I am never interested in 500 milliliter. What am I interested in? 1 liter. 1 liter का मतलब 1000 milliliter. Yeah, that's 1 liter. So come on, unitary method. अगर 500 ml का वजन 0.5 grams है, तो 1000 ml will weigh how much? Obviously 0.5 plus 0.5. 500 ml is 0.5 grams. 500 ml is 0.5 grams. 0.5 plus 0.5, the total 1 gram. So the weight is going to be 1 gram. Okay. And now you can say that the vapor density is weight of 1 liter of gas X upon weight of 1 liter of hydrogen gas. So this is 1 gram and hydrogen is 0.09. It's given. 1 liter का वजन दिया है, STP. These all things should be at standard temperature and pressure. The formulas are valid only at STP conditions, not at any other random conditions. Then only I can use these formulas. So shift 100 upon 9, that is 9 ones are 9, 11.11111111, it goes on, it's a recurring number. So that is your vapor density. Now if someone asks me about the molecular weight, molecular weight formula is 2 into vapor density. That is 2 into 11.11 and that makes it 22.22. Are you getting it? That makes it 22.22. That should be your molecular weight. Okay, grams. So obviously these are weights, na? It's in grams. Okay. Second question. Check the second. A gas cylinder holds 85 grams of a gas X. It holds 85 grams of a gas X. Okay. The same cylinder with hydrogen holds 8.5 grams under similar conditions of temperature and pressure. That is STP. It's given. STP conditions are already given to me. So a direct formula. Can I say weight of a gas is how much? 85 grams. And the weight of same volume of hydrogen gas is 8.5 grams. So can I say therefore vapor density is weight of X upon weight of same volume of hydrogen as X. So answer is going to be 85 upon 8.5, and if you calculate, the answer is 10. Molecular weight is going to be 2 into vapor density. So the answer is 2 into 10, which is 20. Question weight is given STP, and second they have mentioned that the volumes of both are the same. It's mentioned they have same volume, right? Okay. That was your second. Proceeding with the third question. Calculate the molecular weight of 290 ml of a gas at 17 degrees Celsius and 1520 mm pressure, which weighs 2.73 grams at STP. Calculate the molecular weight of a 290 ml of gas at 17 degrees Celsius and 1520 mm. So these are my two conditions, my friends. Listen, for the third one guys, two cases. One of the case is at STP and one is a normal case, a gas which is at certain conditions and the same gas at STP. we'll find the volume. I have been told a gas whose volume is 290 milliliters, temperature is 17 degrees Celsius, that is 273 plus 17. 9th standard में हम लोग ने gas equations, gas laws chapter में पढ़ा है. To use the gas equation, we'll have to convert the temperature to Kelvin. So it makes it 290 Kelvin. And the pressure is 1520 millimeter Hg. Okay. Now for a standard temperature and pressure, we have to find out the volume. Temperature has to be 273 Kelvin and the volume and the, I beg your pardon, the pressure is equal to 760 mm Hg. So according to gas equation, P1 V1 upon T1 is P2 V2 upon T2. Substitute 1520 into 290 upon 290 is P2, which is 760 into V2 upon 273. 290 vanishes, 760 2s are, so cross multiply, the volume will be 2 into 273, 3 2s are 6, 7 2s are 14, that's going to be 546 milliliter. This is the volume of mera gas at STP. My gas at STP occupies a volume of 546 ml. 546 ml, yes. Okay, now what? What next? What is asked? Listen, it's told that at STP, my gas weighs how much? It weighs 2.73 grams at STP. Alright. So can I say at STP, the weight of the gas is 2.73 grams. That is, can I say 546 ml? 546 ml volume का वजन 2.73 grams है. Then can I say 1 liter volume, 1000 milliliter volume का वजन कितना होगा? Why am I insisting on 1 liter? Because in the formula we have 1 liter, which is 1000 milliliters. 1000 milliliters for comparison. That is the reason why I am finding out the version of 1 liter of gas, because this is at STP. So you cross multiply, you get answer as 2.73 into 1000 upon 546. So 2730 on multiplication upon 543. 1s are, 2s are, so answer is going to be 5. 5 grams it will occupy at 1 liter. And hydrogen ka 1 liter ka vajan is 0.09. So vapor density is the weight of the gas, which is 5 grams. This one, weight of 1 liter gas at STP. It's 1 liter ka vajan. First we had 546 ka vajan. So we got 1 liter ka vajan as 5 upon 0.09. That's 500 upon 9. 9 5s are 45, carry forward 5. 9 5s are 45, carry forward 5. 55.55. And if you multiply this answer by 2, definitely it is going to give me the answer of molecular weight. So 55.55 into 2, that shall give me the molecular weight of my gas X. Right? Let me check the answer. Yeah, multiply by 2, you get 111.111111. It goes on. Okay, so it was a wonderful question. First, what we did was, I have told you time and again that these formulas can be used if and only if the gas is at STP. So what I did was, I found out the volume at STP. I got the answer as 546. Nahi chalega, kyun? Because according to the formula, a volume of hydrogen and the gas should be the same. So what I did was, I converted 546 to 1000 ml, and definitely the volume was at 1000 ml because hydrogen is also at 1000 ml. So if both the volumes are same, I got the weight of the gas. मुझे क्या मिला? मुझे गैस का वजन मिला, और एक बार गैस का वजन मिला at 1 liter, I can say that yes, 5 grams is what I get the weight of the gas at 1 liter, and weight of hydrogen is 0.09. So when you divide both of them, you get the vapor density. Multiply the answer by 2, you shall be landing up with molecular weight. So guys, go through these 3 questions. We shall proceed further down with 4 more sums based on vapor density. Next question, 4th one. The question is, state the volume occupied by 40 grams of hydrocarbon, which is methane CH4, at STP if the vapor density is 8. Right. So in the 4th question, vapor density is given to me as 8, and I have been given volume occupied by 40 grams. That is, the weight is 40 grams. Hydrocarbon is methane. Guys, can I say that this sum is actually not based on the formula of vapor density. It is based on Avogadro's law, the mole concept, the katha, the story. What I do is, with the help of vapor density, can I find out the molecular weight? Of course I can. Molecular weight is 2 into vapor density. That is the only reason why they have put this question in the vapor density ka concept. So the molecular weight of the substance, the hydrocarbon, is 16 grams. And then can I say that 1 mole of a substance occupies the molecular weight and occupies 22.4 liters. It's my katha, it's my story. 1 mole of that CH4 occupies molecular weight, which is 16, occupies 22.4 liters at STP. So if 16 grams occupies that weight, 40 grams will occupy how much? 16 grams, which is the molecular weight of CH4. If it occupies this much volume, then 40 grams, which is there with me in the bag, 40 gram ka CH4, how much volume will it occupy? Cross. 16x is 40 into 22.4. You can write 224 upon 10. The shift of decimal, 4 ones are 4 fours are 4 ones are 4 fives are 20, 4 six are. So it occupies 56 liters. Normal calculation, 0 cut and side cut with a table of 4. So can I say that CH4 ka 40 grams will occupy a volume of 56 liters. 5th question. Calculate the atomicity. Atomicity means that N, chota n. Atomicity of a gas whose vapor density equal to the atomic weight. So can I say atomicity, it is weight of a substance, out here it is a gas, upon atomic weight. Atomic weight, yeah. Okay, so you can say weight of the gas, vapor density is equal to the relative atomic mass. Okay, so out here, this is going to be, weight means you can say molecular weight out here. That is 2 into vapor density upon atomic weight. Because molecular weight is 2 into vapor density. That's molecular weight. Question may they have mentioned vapor density is equal to atomic weight. In the question it is mentioned, it is given that vapor density is equals to the atomic weight. So obviously ये cut हो जाएगा. So the atomicity of this gas is 2. Atomicity represented by N. Board exam you write the complete thing. Atomicity is equals to 2. Listen, it's a formula, molecular weight upon atomic weight. Come on, you remember the chapter? In this chapter we have studied empirical formula. Yeah. Don't we have the formula of N as molecular weight upon atomic weight? Don't we have this? Of course we do. And what is molecular weight? 2 into vapor density. And specially, please read. It's mentioned in the sum, the question, that vapor density and atomic weight is the same. Last question for this variety from my side. Calculate the relative molecular mass and the vapor density. So basically molecular weight and vapor density is to be obtained. Of 160 gram of methanol having a volume 112 liters at STP. Okay, so we have 160 grams occupies 112 liters. Then how many grams should occupy 22.4 liters? Why? Because this is my standard value. My STP condition always is at 22.4 liters. Please, it is always said that 22.4 liters volume pe, I will always get the molecular weight. At this volume, when we use a unitary method, you always get the molecular weight. Always. Hence, I took 22.4. So, this is given. 160 grams occupies this much liters. What would be the molecular weight to occupy this many liters? Cross multiply. You get 160 into 22.4, shift of decimal, and at the bottom 112. Ones are, twos are. So you have x as 16 into 2, 32. And this is nothing but the molecular weight. So the molecular weight is 32. Molecular weight is 2 into vapor density, 32. So vapor density is 32 over 2. Vapor density milega 60. So that is the vapor density of the gas. So go through these questions, guys. And now we are going to go with the last type of the chapter, which is called chemical equations. The last part of the chapter, the chemical equations. Okay, chemical equations. If you want to master this, students find this very difficult. It's very simple. अगर इसको master करना है ना, just follow the 4-step process. 4-step process. Just blindly. Step number 1. Write down the balanced chemical equation. Balanced chemical equation लिखो. First step. Second step. जो required है according to the question, write down their molecular weights. Molecular weights of the required compounds. Step 3. Write down the given weights. Majority of the sums ना step 3 पे खत्म हो जाएंगे. But some sums will need step 4. When to use step 4? Whenever they have given volume or number of moles or number of molecules. When they are asking about any one of these, we go to step 4. And what is step 4? Step 4 is katha, story. You remember the story? Of course you do remember. 1 mole of any substance weighs its molecular weight, gives me the molecular weight, occupies 22.4 liters, occupies 6.023 into 10 raised to 23 molecules. You remember, this is called katha. When to use katha? When to use story? When volume, number of moles, number of molecules are given. Varna nahi. Varna third step पे ही तुम्हारा sum समाप्त हो जाएगा. On the third step itself, the sum ends. But when these three things are asked, then only we go with this. Let's talk about 7 to 8 questions based on chemical equations. First, read or listen to the sum carefully. Calculate the weight of potassium nitrite formed by decomposition of 15.15 grams of potassium nitrate. I'll tell you, don't worry, it's okay. You can rewind and you can listen to the speech I gave. First is balanced chemical equation. Potassium nitrate on thermal decomposition gives me potassium nitrite and oxygen. This is the reaction. If you balance it, my friends, this is going to be 2, this is going to be 2, and I think 4 plus 2, that's balanced. Rule number 1, done. 1 water. Second, write down the molecular weights. Isme they are only talking about potassium nitrate, potassium nitrite, potassium nitrate, potassium nitrite. They are not talking about oxygen at all. Oxygen के बारे में कोई जिक्र नहीं हुआ है. There is no mention about oxygen. So I will write down only the molecular weight of the required compound. Required. Potassium nitrate and potassium nitrite. So this is going to be 2 times. Potassium, I think it is 39 grams. Nitrogen is 14. Oxygen 16 3s are 48. And potassium nitrite 2, 39 plus 14 plus 16 2s are 32. Okay, so this is going to be 2 into, these are the molecular weights. 39, 49, 50, 98, 103 I guess. देखना 40, 50, 90, 98, 103, 102. बराबर है क्या? 12 कैसे 102? 101 होना चाहिए. What am I doing today? I don't know. 40 and 40 कितना? 80, 90, 89, 93 and 8, 101. So 2 into 101 is 202 grams. 39, 40, 50, 53, 55, 85 into 2. That makes it 160 grams. This is your step number 2. So step number 1, this is your step number 2. Now the given weights. Step number 3. वजन जो दिए गए हैं. It is told me calculate the weight of potassium nitrite. इसका वजन ढूंढो. On heating 15.15 grams of potassium nitrate. Simple. If 202 grams of potassium nitrate gives 160 grams of potassium nitrite, then this much will give me how much of nitrite? 202 ग्राम को अगर मैं हीट कर रहा हूं, so the nitrite obtained is 160. तो 15.15 हीट किया तो कितना मिलेगा? क्रॉस मल्टीप्लाई. It's 15.15. Get 1515 shift of decimal into 160 upon 202. You just calculate this. You will get your answer. No need for step 4. Okay. 2 5s are, 2 8s are, 5 1s are, 5 303s are. Then 101 2s are, 101 3s are, 2 4s are. So your answer is 3 into 4. You will get 12 grams of potassium nitrite on heating 15.15 grams of potassium nitrate. Okay. Is this calculation correct? I hope so. Wait. 1515. I'll just check the calculation into 160 upon 202. Yeah, sounds perfect. In my calculation, 101 twos are 101 threes are, right? Okay, that's it. 12 grams. Hope so it's the correct calculation. Next, going on with the next question. Second, copper on reacting with conc H2SO4 gives copper 2 sulfate. Okay, so reaction goes this way. Copper first step plus conc H2SO4, it gives me CuSO4 plus H2O plus SO2, I guess. This should be the reaction. Balance karte. 2 out here, 2 sulfur, 1 copper, hydrogen 4, oxygen 2 plus 4, that's 8, that's balanced for you. So first step is accomplished, balance the equation. Second step, let's read further. 1.28 grams of copper is converted to copper sulfate. So नाम किसका आया है? Copper का name is there, copper sulfate का name is there. Okay. Find the weight of copper sulfate and the weight of acid required. Acid. Well, these three things are named in the question. They are talking about copper, they are talking about acid, and they are talking about copper sulfate. There is no mention about H2O and SO2. कोई mention नहीं है. ठीक है ना? So let's start with writing down the molecular weights of only these three. ये दो की जरूरत नहीं है because there is no mention in the question about H2O and SO2. Copper का weight I'll have to check. 64 grams. H2SO4, trust me, when you add it is 98 grams. And there are two such molecules. So it becomes 196 grams. CuSO4 is 64 plus 32 plus 16 fours are 64. 160 grams. That's the weight of copper sulfate. So these are the molecular weights, not this. This is the molecular weight. Step 2. This will be your step 1. 2 steps accomplished. Step number 3. मुझे बोला है 1.28 grams of copper is reacted. इसका 1.28 grams reacts. So how much will be the acid का weight? How much will be the copper sulfate का weight? Like a unitary method. If 64 grams reacts with 196 grams, 1.28 will react with how much? So you will get X ka answer as 128 into 196, obviously upon 100, and 64. Ones are, twos are. So the answer is going to be 196 into 2 is 392 upon 100. That makes it 3.92 grams. This is the first part of the question. Okay, second part. Second part. Cross multiply with y. 64y. So you get y is equals to 160 into 1.28. Shift the decimal. Yes. Upon 64. 0 cancels, 64 twos are. The answer is 32 upon 10. You get 3.2 grams. That means 1.28 grams of copper will react with 3.92 grams of sulfuric acid to form 3.2 grams of copper sulfate. Yeah. So go through these two questions. Wonderful questions which are based on chemical equation. and follow these steps. It's very, very, very important and crucial steps. Yes. Third question from my side. From the given equation, CaCO3 plus HCl gives CaCl2 plus H2O plus CO2. So I guess the equation is already balanced. That is your step number 1. So in the third question, CaCO3 plus HCl gives calcium chloride plus H2O plus carbon dioxide gas. Balanced करने के लिए, that's it, it's balanced. So step number 1 is accomplished. Step number 2, let's read the sum further. 10 gram of calcium carbonate and a volume at an STP of carbon dioxide obtained is at the same time. Wait. From this equation, calculate the weight of calcium chloride. Obtained from 10 gram of calcium carbonate and also get the volume of carbon dioxide at STP. Question में 3 things are involved. 3 चीजों के नाम दिए गए हैं. Calcium carbonate, carbon dioxide and calcium chloride. So ideally in my step 2, which is writing the molecular weight, I will only be writing the molecular weight of these 3 compounds. That's it. Nothing for HCl, nothing for water. Waste of time, useless. So let's start. Calcium is 40 grams. Carbon is 12 grams. Oxygen is 16 3s are 48 grams. So that makes it total 100 grams. That's the molecular weight of calcium carbonate, limestone. Calcium is 40. Chlorine is 35.5 into 2. That makes it 71 and 40. 70 and 40 is 110. That makes it 111 grams. That's calcium chloride. And carbon dioxide makes it 44 grams. Yes, carbon is 12 and oxygen is 16 2s are 32. 44 grams. This is my step 2, writing the molecular weights. Step number 3. मुझे बोला है calculate the weight of calcium chloride. Calculate इसका weight if 10 grams of calcium carbonate is reacted. Step number 3 is given weights. अगर 100 ग्राम से मुझे इतना मिलता है, 100 gram of calcium carbonate gives me 111 grams of calcium chloride, then 10 grams will yield me how much? Even find the carbon dioxide ka weight. Cross multiply. So you get X is equals to cross 10 into 111 upon 100. The answer is going to be 11.1 grams. That means you will be obtaining 11.1 gram of calcium chloride when you react calcium carbonate of 10 grams. And also talking about Y, cross multiply. 100 into Y, simply I can say carbon dioxide का वजन की बात कर रहा हूं, 44 into 10 upon 100. So you get 4.4 grams of carbon dioxide gas. But carbon dioxide का वजन नहीं पूछा है. They are not asking me the weight of carbon dioxide. They are asking me the volume of carbon dioxide. So for the first time, volume is asked. Katha. You remember? When volume, number of moles is asked, we start with katha. So can I say that 1 mole of carbon dioxide occupies the molecular weight, which is 44 grams, occupies 22.4 liters. Then 4.4 grams, that is how much I get in the reaction. इतना मिला ना मुझे carbon dioxide on reaction. Will give you how much? Cross multiply. So the volume of carbon dioxide is gonna be 4.4 into 22.4 upon 44. You solve this, you get 2.24 liters. That's the volume of carbon dioxide. So my three answers are, what is this answer? And what is, दो ही चीज पूछे हैं. The weight of calcium carbonate and the volume of carbon dioxide. Volume के लिए मैंने पहले weight ढूंढा and then I went with the Katha method to find the volume. So weight is very important. Weight is important. It is vital to find the volume. Right? Okay. Going on to the next question, the fourth sum. Okay. The fourth question is, combustion of butane takes place as follows. They have given a reaction to me, which is a combustion of butane C4H10. So it is this is given in the question. 2 C4H10 plus 13 oxygen gives me 10 water and 8 carbon dioxide. 10 water molecules. First thing, calculate the number of moles. They are asking me moles. Moles matlab I'll have to go with the step 4, which is Katha. Yaad rakhna. Calculate the number of moles of oxygen. Need to completely combust butane of 58 grams. So 58 grams ka butane. And find the volume of carbon dioxide at STP at the same time. So three things are involved in the sum. Carbon dioxide, oxygen and butane. There is no mention about moisture, water. कुछ नहीं है, तो उसको कुछ नहीं करना है. Nothing to be done. So step one is always the balanced equation. Step 2, molecular weights of the ticked marked wala required compounds. Carbon is 12, 12 fours are 48. Hydrogen is 1. So you get 2 into 58. So you get 116 grams of butane. Okay. Out here, oxygen is needed. So 13 into oxygen is 32. 32 into 13. Bapre. You'll have to calculate. 32 into 13. 3 2s are 6, 3 3s are 9, 3 2 0. 416. And carbon dioxide is 8 into 44. 4 8s are 32, carry forward 3, 352 grams. This is your step number 2. Okay, so we are on two steps, step 1 and step 2. Okay, guys, now listen to me. Question में क्या बोला है? 58 grams of butane का combustion हुआ है. 58 grams. The given weights. 58 grams of butane will give me how much oxygen and how much carbon dioxide. Let's find out. ठीक है ना? Cross multiply. 116 will give me 416, so 58 will give me how much? So I can say X is equals to 58 into 416 upon 116. 1s are 2s are 208s are. So the weight of oxygen weight of oxygen is 208 grams. Talking about carbon dioxide, why? If 116 gives 352, 58 will give me how much? So answer will be 58 into 352 upon 116. 2s are and 176 are. So Y is going to be 176 grams of what? Carbon dioxide. So that's oxygen and this is carbon dioxide. Now in the question, what are they asking? Question mein they are asking me about first number of moles and the volume of carbon dioxide. इसका number of moles पूछ रहे हैं और इसका volume पूछ रहे हैं. So I'll have to go with the Katha method. 1 mole of oxygen occupies molecular weight which is 32 grams occupies 22.4 liters. जरूरत नहीं है. Then how many moles will occupy 208 grams? So you get number of moles is going to be 208 upon 32. 16 के टेबल में 16 ones are 16, 16 threes are 48, 16 twos are. The answer is 6.5 moles. 6.5 moles. Okay. And the second part, इसका वॉल्यूम पूछा है. कथा 1 mole of carbon dioxide occupies 44 grams HTP, occupies 22.4 liters. Then 176 gram of carbon dioxide will occupy how much? Cross multiply, you should get the answer. It's gonna be into 4, na? 22.4 into 4 will be the answer, 89 point something. It's gonna be 89.6 liters. That's it. And this answer was 6.5 moles. Beautiful question. We maintain the simple process. Process में what do we maintain is that listen. जो चाहिए उसका molecular weight लिखा. Okay, given weight से we found out the required weights, and वजन से with the weight of oxygen and with the weight of carbon dioxide we found out their volume and we found out the number of moles. Okay, mark this as an excellent question, a difficult sum, this one. So this is the fourth question from my side. Mark this as a star sum, where you had to find the moles and the volume. The next two sums which I am taking are dangerous sums. Okay, difficult they are, it will take time, going slow. The question is, there is an equation given to me, copper plus nitric acid. It's given a board exam, it will be mentioned, this equation. Step 1. This is a fifth question from my side. Copper plus 8 HNO3 gives me CuNO3 twice H2ONO. CuNO3 twice H2O plus NO. And balance में 3, 3, 4, 2. 3, 3, 4, 2. This is your balanced condition. Step 1 they have given, so I don't have to worry much about. आगे बढ़ते हैं. Find the mass of copper. Copper की बात चली. Find the mass of copper needed to react with 63 grams of nitric acid. We also spoke about nitric acid. 63 grams के साथ कितना कॉपर की जरूरत पड़ेगी? Okay. Calculate the volume of nitric oxide. इसका वॉल्यूम. Okay. And for the same 63 grams of nitric acid. There is no mention about copper nitrate and water. So उसके molecular weight की जरूरत नहीं है. So step number 2. Whatever I have ticked, find out उसका वजन. Find out the weight. Copper is 64 grams, I think. So it's going to be 3 into 64. That is 4 threes are 12, 192 grams. 8 into hydrogen is 1, nitrogen is 14, oxygen is 48. 16 threes are. So you get 63 into 8. 8 threes are 24, carry forward to 504 grams. And 2, nitrogen is 14, oxygen is 16. 32s are 60. So, can I say 192 grams of copper react with 504 grams of nitric acid to give me 60 grams of nitric oxide. This is the weight which reacts in general. My step number 3. Step 3 is given weights always. 63 grams is given. What should be the weight of copper and what should be the weight of weight of nitric oxide? Cross multiply. So you get X is equal to 63 into 192, the whole upon 504. 192 4 जा नहीं, 63 के टेबल में जाता है. 63 8 जा, 8 3 जा 24. हाँ शायद 24. हाँ डायरेक्टली 8 जा 16 24. So I will get 24 grams of copper reacts with 63 grams of nitric acid. ठीक है. And also find the value of Y. Please find the value of Y. Come on. Y is equals to cross multiply 60 into 63 upon 504. 63 8 za, 4 15 za, 4 2 za. The answer is 7.5 grams. इतना नाइट्रिक ऑक्साइड का वजन मिलेगा when 24 grams of copper react with 63 grams of nitric acid. I will get 7.5 grams of nitric oxide. नाइट्रिक ऑक्साइड का वजन नहीं पूछा है, नाइट्रिक ऑक्साइड का वॉल्यूम पूछा है. वॉल्यूम. To find the volume, I have vajan, I have weight. Let's find the volume. Step 4, 1 up. Step 4 is the katha. 1 mole of NO occupies the molecular weight which is not 60. Please. Molecular weight is only NO, which is 30. So 1 mole of nitric oxide occupies the vajan 30 grams, which occupies 22.4 liters of volume. Then 7.5 grams will occupy how much? Calculate karo. It's gonna be divided by 4 divided by 4 करोगे तो आंसर आ जाएगा. It's a trick. Come on यार, ये इसका 1/4 है. You divide 30 by 4, you get this answer. You divide this by 4, you will get this answer. That's the trick. Answer will be 5. 4 5s are 20.6 liters. That should be the answer. That is the volume of nitric oxide which will be obtained or which will be formed when copper of 24 grams reacts with nitric acid of 63 grams. Sixth question. Sixth question is a very difficult sum. Try करता हूँ. Okay, we have a backward process. पूरा reverse calculation है sixth sum में. Reverse. Excellent question. It's one of my favorites. The question is 2 volumes of KClO3 on heat gives KCl plus O2 2 KCl plus 3 O2. And there is one more reaction. C plus O2 gives CO2. Two reactions given. Question में है, the question states calculate. देखो पूरा reverse psychology है ये sum. Calculate the amount of KClO3. इसका वजन ढूंढना है. Okay, which on decomposition gives X volume of oxygen. It gives me some volume of oxygen. Whose volume is required for 24 grams combustion of carbon. Shit. Okay. Look at the reverse psychology. 1 minute. Of carbon. Yeah, that's it. It's classy. इसको हीट किया. I heat this. I get oxygen. Same oxygen जितना भी मिला, complete package, total oxygen, the complete amount, the complete volume, पूरा oxygen मैंने इधर डाल दिया. I use it out here. For complete combustion of carbon, I heat it with carbon to form carbon dioxide. So I am going to go reverse. First focus on this much, only this much. ठीक है ना? Okay, how? Let's find out the volume of oxygen out here, which is actually the volume obtained in that step. अरे जो ऑक्सीजन इधर से मिला, the oxygen which I got from here, same oxygen I'm using out here. So let's start with the second part first. Either this one. Okay. So let's begin. How do I solve? Anything else is given? Let's see. No. Only 24 grams combustion of 24 grams of carbon. Okay, no issues. Let's begin the show. I'll start with this one. First, balance the equation. It is balanced. Step 1 over. Step 2, carbon का वजन is 12 grams. Molecular weight 12 grams. Oxygen का molecular weight is 32 grams. So if 12 grams of carbon reacts with 32 grams of oxygen, then 24 grams which is given, इतना कार्बन को जलाना है, 12 ग्राम को नहीं जलाना. You don't want to जलाओफाई combustibility में. You don't want to hit 12 grams. You want to actually hit 24 grams. How much oxygen is needed? If 12 grams combustion के लिए we need 32 oxygen, 24 combustion के लिए we want how much oxygen? It's a double. So on calculation, answer will be 64 grams of oxygen is needed for the combustion. और ये ऑक्सीजन कहां से मिलेगा? From where will I get this oxygen? From there. So can I say that is that has to be 64 grams because this oxygen completely is used out here. So this is the reverse psychology. Therefore, 64 grams of oxygen is available from the first equation. There. So I can write 64 grams is formed. इतना form हुआ जो आगे use हुआ. So the formation of oxygen out there is 64 grams. That is only complete usage out here na, for this 24 grams का combustion to happen. Okay. Now I'll just rewrite this. 2 KClO3 gives 2 KCl plus 3 O2. Okay, I'm just focused on these two things. इसका molecular weight, potassium is 39, chlorine is 35.5 and oxygen is 16 3s are 48. That is 2 into 39, 48. This is going to be 87, 97, 107, 117, 122.5. Multiply with 2, you get 245. That's the molecular weight. And this is 3 into 32, 96. That means if you hit 245 grams of potassium chlorate, you get 96 grams of oxygen. But how much was the oxygen formed? Can I say only 64 grams of oxygen was formed actually? Itna form hua tha. That is obtained from how much potassium chlorate? Cross multiply. So Y is equals to 64 into 245 divided by 96. 32 2s are 32 3s are. So the answer is going to be 490 divided by 3. 163.33. This is the amount of potassium chlorate needed in order to get 64 grams of oxygen, which will eventually help in combustion of 24 grams of carbon. So the answer should be how much? 163.33. It's a reverse psychology. Okay. Excellent question. Excellent question. It's one of my favorite sounds. Okay. Go through this, and now we're going to go with the last 2 to 3 sounds for our chapter to get complete. Okay, the next question. Question is, from the equation ammonium dichromate. Equation दिया है question में NH42Cr2O7. Okay, on heating gives N2H2O Cr2O3. 9th standard में था ये. N2 plus 4 water molecules plus Cr2O3. Balance भी दिया है वो लोग ने, so we'll just check it out. 4H2O and that's it. It's balanced. This is balanced. You can check it. Yes. So step number 1 is accomplished. Step number 2. Let's see what is given in the question. Okay. It is said, calculate the quantity in moles of ammonium dichromate if 63 grams of ammonium dichromate is heated. Okay. 63 grams of ammonium dichromate is heated. Find the number of moles. Second, calculate the number of moles of nitrogen, the volume of nitrogen, and the mass of Cr2O3. बापरे. इसका number of moles, इसका number of moles और इसका mass, everything is required. सबकी जरूरत है. You'll have to find the molecular weight. Come on. इसका molecular weight, नाइट्रोजन 2 है तो 14 2s, हाइड्रोजन 4 2s 8, ऑक्सीजन 16 7s, 16 7s कितना होता है 102, एंड क्रोमियम 2 है. व्हाट इज द वजन ऑफ क्रोमियम? आई डोंट नो. 52 दिया है क्वेश्चन में. 52 2s 104. ये 16 7s कितना होता है? 16 7s 7 6 42. एक मिनट. 16 7s पर भाई रिस्क नहीं लेना है ना. 7 1s 7 and 4 8 9 10. It's 112. देखा? That's what I keep on telling you. It's 112. Okay. So इसका वजन होगा 216, 226, 236, 244, 252 grams. So ammonium dichromate का molecular weight is 252 grams. Nitrogen is going to be 28 grams. Water is going to be 4 into 18, which is 72 grams. And Cr2O3 will be 52 2s. 52 2s 104 plus 48. 104 plus 48, 148, 152 grams. Khatarnak समय. Okay. So these are the molecular weights. This is for ammonium dichromate, nitrogen, water and chromium oxide, Cr2O3. ठीक है. Question में क्या बोला है? Question में it is said 63 grams of ammonium dichromate is heated. 63 grams. Oh God. Oh God. So what will be the वजन? पहले वजन की बात कर मेरे साथ. Talk about the weights first. Let's find the weights of all of them. Cross multiply. X 63 into 28 upon 252. 63 4s are and 4 7s are, so X is going to be 7 grams. Why? Cross multiply. 63 into 72 upon 252. 63 4s are and 4 1s are, 4 18s are. You get 18 grams. Z 63 into 152 upon 252. 1s are, 4s are, 4 3s are 12, 4 8s are 32. 38 grams. That means जब भी 252 ग्राम्स का अमोनियम डाइक्रोमेट को तुम लोग जलाओगे, you will get this much of the individual products. But we are not heating 252 grams. That's just the molecular weight. वो खाली मेरा reference है. Actual में, test tube में, how much am I heating? I am heating only 63 grams. So with 63 grams of heat, मैं test tube में इतना ही जला रहा हूँ. I am getting 7 grams of nitrogen, 18 grams of water moisture and 38 grams of Cr2O3. These are the actual products formed in my test tube when I am heating 63 grams of ammonium dichromate. Question में पूछा है find the number of moles of nitrogen and water. Moles पूछा है और Cr2O3 का तो वजन पूछा है. So one of my answers is 38 grams. Okay. Number of moles. Katha. 1 mole of nitrogen occupies 14 into 2, 28 grams. But in the test tube, कितना ग्राम फॉर्म हुआ? सिर्फ 7 ग्राम. So how many moles will form 7 grams in my test tube? Cross multiply. So I get number of moles of nitrogen is going to be 1/4, which is 0.25 moles. Next, Katha again. Okay. 1 mole of moisture, water, is 18 grams. पर मेरे टेस्ट ट्यूब में कितना फॉर्म हुआ है? 18 grams ही फॉर्म हुआ है. In my test tube, I am getting 18 grams of water. So can I say my answer is 1 mole only, which is the molecular weight. So my one answer is 0.25 moles of nitrogen. Second answer 1 mole of water. Third answer 38 grams of Cr2O3 is obtained during this reaction. So I hope you are getting these sums. This is my 6th or 7th. I'm not sure. 7th है. Last question for this type, 8th. Okay, the equation given to me is aluminium carbide Al4C3. Nice, sir. Aluminium carbide. Okay, it's reacted with moisture, 12 volumes of moisture, to give me 4 ANOH thrice, and a reaction is given, don't worry, plus 3 methane. It's given, don't worry. Okay. State the mass of aluminium hydroxide formed from 12 grams of aluminium carbide. Also the volume of methane. Fine. These are the 3 things involved. Water का कोई जरूरत नहीं है. There is no need of water or moisture. Molecular weight of Al4C3 is 144 and aluminium hydroxide is 78. It's given. They are very sweet. So step 1 दिया है. Step 2 molecular वजन. इसका वजन is given as 144 grams. Moisture की जरूरत नहीं है. Aluminium hydroxide is 78 into 4 plus methane is 3 into 16. So 48 grams. 8 4s are 32. 28 and 3. 31. This is your step 2. Step number 3. Step number 3. Molecular weight हुआ. क्वेश्चन में क्या बोला है? 12 grams of aluminium carbide. Test tube में we don't have 144. That's a reference. I am carrying out this reaction with only 12 grams. सिर्फ 12 grams है मेरे पास test tube में to take forward this reaction. So what will be the वजन of methane? वजन, पहले वजन ढूंढो. वजन of methane and वजन of aluminium hydroxide. Cross multiply. So you get X as 12 into 312 upon 144. 12 12s are 12 ones are 12 और 2s are 24. नहीं 12 के टेबल में नहीं जाता है. What about 4? Yeah, 4 3s are 4 7s are 28. 4 8s are okay. So 78 upon 3. That is 3 2s are 6. ये जाता है 26 grams. What? I also know. जाता है. Sorry. So 26 grams. That means अगर मैंने 12 ग्राम एल्यूमिनियम कार्बाइड I react it with water, I will get 26 grams of aluminium hydroxide for sure. And how much will be methane? Let's find out. Cross multiply. 12 into 48 upon 144. 12 12s and 12 4s. You get 4 grams of methane. And 26 grams of AlOH thrice. Okay, PPT. Question में क्या पूछा है? What is asked? Find the volume of methane and the mass of aluminium hydroxide. This is one of my answer. The mass of aluminium hydroxide is 26 gram. And इसका volume पूछा है. Mass नहीं पूछा है. But we want mass. कथा. Step 4. 1 mole of methane occupies molecular weight which is 16 grams, occupies 22.4 liters. But मेरे टेस्ट ट्यूब में कितना मीथेन है? 16 grams नहीं है. I have obtained only 4 grams methane in my test tube. Will occupy how much? So can I say volume of methane 4 into 22.4 upon 16 solve करने पे आंसर आएगा 5.6 liters. Yeah? So guys, with this we complete our chapter. Chapter was divided into 6 parts. The first part, Gay-Lussac's law, percentage composition, Avogadro's law. Then you can talk about, with Avogadro's we had mole concept, empirical formula. Fifth was vapor density sums, and sixth was chemical equations. Right? It is a chapter which requires a lot of practice. Use my tricks, use my tactics. You will easily swim through the chapter. Yeah. So hope to see you till the next chapter.